All right, ladies and gentlemen, thanks for your attention. We're just going to start. We hope everybody on this side is all right, and that the sound is all right, and the stage is not going to break down in the next 15 minutes. So, welcome to our talk. We're going to talk to you about how we use AI in order to support complex business decisions, especially in the AI field. And as she suggested before, it is actually quite a mouthful. We actually checked; it might be one of the longest titles of the whole conference, 15 words. And actually, Jacqueline, I think this is something that we can be a bit proud of now.
Yeah, I think you should use your AI skills and try break it down to the essence, because I think most people stop reading after one line.
Yeah, I think that's actually true. So maybe as a first beacon how we can use AI, let's have our GPT summarize our own title, so condense it down to one line. So what do we actually want to say? What we want you to be decision heroes. This
All
is
right.
quite catchy now, no?
I think it's pretty good, but I'm missing the sustainability focus of our topic a little bit. So
You're missing the sustainability focus. Okay, fair enough. We can also solve that by GPT. So give us a second line, please, focusing on sustainability. Also quite catchy, please. Can we save the planet? Is that good now?
that's pretty good. I'm happy with that. But I think at the moment the design is kind of boring. So if you could use your AI skills again to make it more suitable for the event.
Of course, we can also generate a background that suits the high-tech AI conference here. So please,
All right.
are you happy now?
That's really good. Thank you for that. So I think we're not going to single-handedly save the planet today, but in this topic, I think the ambition level definitely should be high. So our main point still stands. We developed an AI pipeline that helps make complex and well-rounded and data-driven decisions. So maybe before we get into the topic, I'm going to quickly tell you who we are and where we come from. So the Wirtspartner Group is about 40 years old. We were founded in Switzerland, more precisely in Zurich. And the company has grown within the country itself and then expanded to other countries within Europe. And we have also grown unorganically. We have 3 subsidiaries that mostly concern themselves with data science and sustainability topics. And we are a consultancy company, and from our origination, we've basically tried to combine human and digital intelligence, because we think this leads to the most successful and useful results. So now more than ever, we try to do that, of course, with the digital intelligence evolving pretty quickly. In the real estate, but also in the finance industry, we are faced with complex decisions every day. And this also goes for the topic of sustainability, of course, and that was kind of the starting point from developing this AI pipeline. And Severin, you're going to tell us a little bit more about that now.
Exactly. So the goal of the AI pipeline you mentioned is actually quite simple. So we want to provide the best possible databases for every complex decision. And as you mentioned, it is a 3-step AI pipeline. So let's go through the 3 steps that we employ to do exactly that, to build the databases for the decisions. Step number 1 is the raw data step, let's call it. Obviously, as Sherlock Holmes said, so we cannot make bricks without clay. So we need data first. We extract key variables directly from the environment by means of deep learning directly from visual information. So we extract information from images, for example, as you will see in the examples afterwards. This is the step 1, the clay. Step 2, we model critical factors for every decision. So from the clay, we basically build the bricks. We have machine learning models in place that predict all the critical variables that we need for a given decision. And then obviously step 3 is we establish a virtual decision environment. Picture a digital playground that contains all the variables that you need in order to take this decision. And you might sense already that this is quite powerful, but it's also obviously quite generic. So let's go through one specific example, how we employ with our current customers these exact 3 steps. And the example that we want to talk about is the CO2 footprints of banks. So imagine you're a bank and you face the following challenge. You want to reduce the emissions of your mortgage portfolio. So actually, this is one of the challenges our clients face every day. And this is also one of the challenges for which we employ exactly these 3 decision steps, or these 3 AI-driven steps. Step 1, obviously, in this context, would be to extract the emission-relevant variables from the environment. So we need raw data, everything that is important or relevant for emission. The second step would be to feed our ESG models. So we plug the data we obtained in step 1 into the ESG models, which we will talk about, in order to then, in step 3, understand the total footprint and to be able to base our decisions on this big picture footprint. So these 3 steps we want to go through step by step and show you a few more details. Step 1 then. So obtain key variables directly from the environment. And one of the sustainability relevant variables you see on this picture here. So what can be sustainability relevant on this picture? One thing that we know and use a lot is the window to facade ratio, because all other things equal, the larger this ratio is, so the larger the windows relative to the facade are, the less energy efficient a building is. And obviously, this information is contained in the image, right? So we can see that larger windows is obviously a larger window to facade ratio. And we have a deep learning system in place, our IMO-I network, which is based on Datacron 2 from Meta and trained on thousands and thousands of street view images. It is actually able to detect, to segment the images, and to calculate the window to facade ratio. So on the image on the right, the true value, which we measured by hand in this case, is 31%. So 31% of the whole facade is our windows. What our algorithm does, IMO-I does, is to segment the facade. So it actually detects what is window, detects what is facade, and calculates the ratio. And in this case, the AI prediction would be 32%. So quite close, as you see, quite accurate, but it's obviously kind of a cherry-picked example. But the good thing is you don't have to take my word for it. You can come to our booth and actually test out this very algorithm. So we are in booth C40, and we have, as you see on the right, a demo app in place where you can try and beat our AI, actually. The main point here, though, being that we can extract sustainability-relevant variables directly from the environment. Everything that is basically encoded in images, we can extract by deep learning and plug them into the next models, such as the window to facade ratio. And this is passed on to the ESG models, and I will pass this on to you, Jacqueline.
Thank you. So we take the variable generated from step 1 and plug them into our machine learning-based sustainability models. So as Severin mentioned, the window to facade ratio helps us to increase the accuracy to predict the energy efficiency of a building. But we also use the models to predict the most probable heating carrier, for example, based on the building's exterior or information that we have additionally on the building. We also use it to try and estimate the last refurbishment year in a relevant way for the energy efficiency of the building. And in a more economic context, we use models to automatically derive market trends, also depending on information that we have on the building, and also maintenance and running costs. And this then enables us to predict the greenhouse gas emissions of a building, but it also helps us to calculate some implications that this might have on property value. So a green building might be more valuable than a non-green building, or the other way around. And also we're trying to predict the costs necessary to reduce the emissions according to a set reference reduction pathway. And in the final assessment in step 3, we now try to create this optimal decision-making environment. In our example, this would be to establish a digital mirror of the building stock where all the relevant variables and measures, so measured or modeled, are contained so that we can have very efficient sustainability calculations on the spot. And as mentioned from Severin in the beginning, if you're trying to calculate the carbon footprint of a mortgage portfolio, your biggest problem is data availability. So with that, with the pipeline that we established now, we have helped this difficulty, and we have actually established the digital representation of all buildings, which now allows us to do this sustainability calculation and ultimately to calculate the carbon footprint of the whole mortgage portfolio.
Yes. So let us review this example then again. So what have we actually done? The CO2 footprint example, we faced a challenge. We wanted to reduce the total emissions of our mortgage portfolio. We have gone through these 3 steps. The goal, so let's start from the very right, was to have a total understanding of the carbon footprint. In order to achieve this, we had to model certain variables as greenhouse gas emissions, as certain other variables that you mentioned. And in turn for this, we needed the clay that we mentioned in order to build the bricks, the raw data, which we extracted directly from the environment. And this was the specific example, but remember, this is actually an algorithm, if you want, or a pipeline that is applicable quite generically. So from the left, we extract key variables from whatever visual information that is present. We plug them into the machine learning models that are specifically made for the decision we face. And then on the right, we can establish the digital playground, as we call it, for every decision, so that you can actually, or we can actually, or our clients can actually take and try out different implications of their decisions. And with that, we are absolutely convinced that we can provide the best possible databases for every decision. And to close the loop to the very beginning, we can be decision heroes with this 3-step pipeline. You can do that too. And together, if we apply this, we're convinced that we can also save the planet. And in that sense, thanks for your attention. And again, please meet us at our booth. We can go into further details, also technically, if you want. We are at booth C40. Thanks a lot.
Thank you. Thank you to both of you for that. I'm going to ask you a hairy question because I like the challenging questions. When you're looking at environmental impacts of buildings, what impact is that going to have on people's property prices, and should we care? And then I'm going to open to the floor, so if you have other questions, I would love to hear some of them.
Actually, we've done quite some empirical studies on that, and you can already see that it has an effect on property values. Because also with regulations, in some countries in Europe, there is regulations that you can't generate rental income depending on the energy efficiency of the building. So it is logical that it has an implication on property value. So yeah, I think that will come more and more. In general, more general terms, I mean, you can only have a financial impact if people know about it once they decide about the price. So the more awareness there is and the more knowledge and data about this, the more the effect will be on the price.
And I'm going to ask one more question before we go to the floor. Does anyone have questions? Put their hand up for the mic to come out. Up the front here, if we can grab a mic. How about people who can't afford to make these changes to their houses to make them greener? Is this going to create a greater financial divide between the wealthy who can and the poor who can't improve their properties?
Good question.
I may have worked in this area before.
I mean, a lot of governments establish subsidies to try and help people. But yeah, I guess it will definitely create a gap, I would say. But that's my personal opinion.
Obviously, that's not your professional opinion. Thank you for being so. Question from down the front.
Yes, yes, I had a question regarding the emissions of a building. I mean, you also look to the installations, aircos, heating systems, lighting as variables in a building?
Yeah, so on a general basis, yes, we do. But in this mortgage portfolio context, we can't always, because that is very specific data to the building. And if you're already lacking, for example, the construction year of a building, it's still way in the future to know about their cooling. system and so on. But yeah, definitely that's the goal. And from if you know a building and if you go look at a building, of course you have to take all of that into consideration.
And you can do that. You
Yes.
can make a digital twin of that.
Yes, of course. Yeah.
I think we have time for one more question. Does anyone have a hairy question? Boring question? Any question?
As long as it's not about teenage sex, it's okay.
Yeah, no, we're not answering. We don't talk about that here. It's not really happening. No other questions? If there are no further questions, I'd like to say a huge thank you for the presentation. Thanks for answering my difficult question, and thanks to everyone for listening.
Thank you.